David Spears, Civil Engineering Instructor at Texas Tech University, talking about statics, CE 2301. We've got a 2D moments problem here to look at. This is we've got a rigid body, kind of that blob, with three forces acting on it at points A, B, and C. And the first part of the problem is we want to know what the resultant moment of the three forces about point A is. Well, first thing I want to do is really get all my forces into Cartesian form. I've got this one F2 is at 16 kilonewtons in the positive x direction, so I don't need to worry about it. But I do want to address F1 in the x. F1 is 20 kilonewtons down and to the left at a 3, 4, 5 slope. So that makes the y part, this vertical, is 3/5. That's a 3, 4, 5. 3/5 of 20. That's equal to 12 kilonewtons. The horizontal is 4/5 of 20, which is 16 kilonewtons. F3 is given to me in Cartesian form, and it says positive 4J, so I've got 4 kilonewtons up, and I've got 4 kilonewtons to the left. Once I have everything in XY Cartesian form, it's a lot easier to work with. So once again, I'm trying to get the resultant moment of three forces about point A. It's this point here, so I don't have to consider anything with F1 because they both F1 intersects point A. So all I have is the moment caused by F2 and the moment caused by those two components of F3. So I'm just going to sum moments about point A. I'm going to say any counterclockwise moment is positive for a sign assumption. Okay, starting off at B, I have the 16 kilonewton. It's trying to rotate, I hope you can see, counterclockwise about point. If I bring it over here to right underneath point A, it's trying to rotate counterclockwise, so it's positive 16 kilonewtons. And it's a x force, I need a y distance, so that is 5 minus 2, or 3 meters. Then I have the force F3, those two components at F3. We'll start off with the 4 kilonewtons to the left, the x component. That's trying to rotate clockwise about point A, so it's negative by my sign assumption. 4, the y distance there, it's an x force, I need a y distance, that's 5 minus negative 3. Note that I don't care about it's not really like a position vector, it's just the magnitude of the position vector because I'm assigning signs by the direction of rotation. So that's 8. 5 minus negative 3 is 8. And then finally I have that positive 4 kilonewtons trying to rotate, I hope you can see, once again clockwise about point A, so it's negative by my sign assumption. 4, it's y force, I need an x distance, that's 4 minus 3, or 1. Do the math. I get 16 times 3 is positive 48. Minus 4 times 8 is negative 32. Minus 4 times 1 is minus 4. And so the answer is 12. And I get a positive 12. The units are kilonewton meters. And the positive means counterclockwise. So that's my answer. Part 2, number 2, resultant moment of the three forces about point C. I'll change colors here, and we'll talk about taking moments about point C. So now I've eliminated F3 because it intersects there. And the sum of the moments about point C, once again, use the same sign assumption, counterclockwise positive. Let's start off at B. 16 is trying to rotate now. It's trying to rotate clockwise, so it's negative 16. And the y distance is 2 minus negative 3, or 5. And then I have the forces at F1, or the force at F1, it's two components. The 16 is trying to rotate counterclockwise, so it's plus 16. The y distance is 5 minus negative 3, again, which is 8. And then I have the 12 kilonewtons here, which is just slightly to the right, so it's trying to rotate clockwise about point C. And so that's negative 12 times 4 minus 3. That's 1. So do the math, and I have 16 times 5 is negative 16, is negative 80, plus 16 times 8 is 108. I'm sorry, 128, and minus 12 times 1 is negative 12. This works out to be positive 36 kilonewton meters. The positive means, once again, I've got counterclockwise rotation. Finally, I want to do the resultant of the three forces about point O. And so that looks like this. Sum of the moments about point O. Same sign assumption. I've started with I'm doing about point O. So I've got 16 trying to rotate at F2. I've got 16 trying to rotate clockwise. So that's negative 16. And really now it's just the y coordinate of point B, which is 2. Plus the 16 kilonewtons up here at F1, which is 6 plus because it's trying to rotate counterclockwise. And so I've got 16 times 5. Then I've got the vertical, the 12, trying to rotate clockwise. It's negative 12 times 4. Then I've got these the components of the forces at F3. I've got the vertical is 4 trying to rotate counterclockwise, so it's positive 4 times 3. And then the x component is trying to rotate clockwise, so it's negative 4 times 3. Do the math, and I get negative 32 plus 80 minus 48 plus 12 minus 12. And all those cancel each other out, and I get 0. So that's my answer.